whether the ordered pair is a solution of negative x plus 2y is less than 8. So what we're going to do for each one of these is plug it into that inequality. So this is negative 0, or 0, right? Plus 2 times 0 is less than 8. This is 8. This is 0 is less than 8. True statement? True. So 0, 0 is a solution. What about 0, 4? That's negative 0, or 0, plus 2 times 4 is less than 8. That's 8 is less than 8. Is that a true statement? Nope, that is false. It is face, because apparently I can never remember the L. This is a false statement. Remember, it's just less than, not less than or equal to. So 0, 4 is not a solution. Let's take this last one. This is negative 3 plus 2 times 5 is less than 8. That's negative 3 plus 10 is less than 8. So that's 7 is less than 8. Is that a true statement? Yes, it is a true statement. Therefore, 3, 5 is a solution. Again, if you're having trouble on those, make sure you reach out and ask a question somewhere in the comments or find me, and we will make sure that you've got it. It is important that you would be able to do this because what we're going to do right now is combine what you just did in those last couple examples. We're going to combine the graphing with these solutions because we got to do both of those things when we graph this. Okay? So remember, so now we're going to graph linear inequalities with two variables. Now, the thing that's really important to remember about this is that a graph represents all solutions. Right? We talked about that in the first slide. A graph represents all solutions. So, how do we graph this with an inequality sign so that it represents all of the solutions? Well, we need to know where possible solutions are. So the first thing that we're going to do is we're going to graph the line. And the way that you graph the line is the same as what we did in the previous unit and what we did on the first couple of slides here. There's a y-intercept at negative 3. There's a slope of 4, and so we connect the dots. Okay. Now let's just test to make sure that these things are solutions, right? So we're going to test it by picking a number on the line. So let's take 1, 1, and let's plug it in and see if it's a solution. 1 is greater than 4 times 1 minus 3. That's 1 is greater than 1. Is that a solution? No, it's not. This is false. This point that was on the line completely is not a solution because it doesn't make a true statement. It's close, but it doesn't make a true statement. Notice that when this was an equal sign, it was a true statement and it was a solution. But because this isn't equal to it, it doesn't work. However, our solutions are going to be on one side of this line. So what we need to do is to determine which side of the line, contains our solutions. And for this line itself, because the line isn't a solution, that means none of the points on this line are going to be a solution. We're going to draw this line differently. Instead of it being a solid line, we're going to draw it as a dotted line. Because we want to represent which side the solutions are on, but we need to say something that says that this line doesn't contain solutions. So we're going to draw it dotted. General way to think about this, if it's a less than or a greater than, it's a dotted line. If it's a less than or equal to or a greater than or equal to, it is a solid line. And yes, that is important to recognize. So let's test to see which side contains our solutions. So I'm going to pick an easy point, and you can pick any point you want. I'm going to pick 0, 0. So is this point a solution? So 0 is greater than 4 times 0 minus 3, which is 0 is greater than negative 3. Is that a solution? Yes, it is. And because this is a solution, it means everything on this side is a solution. Because 0, 0 is a solution, everything on that side will be a solution. So how should we represent that? Everything on this side of the line is a solution. Well, to represent solutions, we had a solid line. But because every single point on this side of the line is a solution, it means we need to somehow represent everything on this side of the line, and the way we do that is by shading it in. When we shade in a side of the line, we're saying that everything on this side of the line is a solution. So this side, none of the points work. These points will all produce false statements. This side will produce entirely true statements. And this is the difference between graphing an inequality versus graphing an equation. Graphing an inequality, you always have to shade a side, because the shading represents all solutions. Let's do one more example before I give you something to do on your own. This is that same one that we did earlier. Okay, let's graph it. This one had a crossed at 0, and what was that? Let's solve for y here. So we're subtracting x from both sides. We get 2y equals negative x, and then we divide by 2. We get y equals negative 1/2 x. So we're going to go down 1, right 2. Oops. And I get that line right there. Now, this is a less than or equal to, which means it is a solid line. So I drew it in solid. Now we need to test which side of the line contains the solutions. So we need to pick a point. Let's test, and again, it doesn't matter. I pick easy points. I'm going to test 1, 1. 1 plus 2 times 1 is less than or equal to 0. So that's 3 is less than or equal to 0. Is that true? It is not. 3 is bigger than 0. So it is not a true statement. So 1, 1 right here, not a solution. Since this isn't a solution, what that means is that all of these are solutions. So I'm going to go ahead and shade this in, but then let's prove it to you here. Let's take the point negative 1, negative 1. So plugging that in, I get negative 1 plus 2 times negative 1 is less than or equal to 0. That's negative 1 minus 2 is less than or equal to 0, so negative 3 is less than or equal to 0. And that is a true statement. So quick summary. Graph the line, and then test points to find solutions. And again, remember, a solution makes a true statement. You've got a couple of these to do on your Canvas assignment. Go ahead and back that up and do it now. All right, so here's the two that you had to do